Welcome to Math 120, Chapter 2.2, Subsets and Set Operations. This video is not intended to be a substitute for reading the book, but as a supplement to the book. So do not substitute the book for this video. You should read the book prior to watching this video. Upon completion of this section, you should understand the following. Define the complement of a set. Find all subsets of a set. Use subset notation. Find the number of subsets. Find the intersection and union of sets. At times, you should pause the video and try to answer the problems and then restart the video. The universal set U is defined to be the set consisting of all possible elements. Those possible elements are subjective with respect to the context of the discussion. What I'm saying is, depending upon what we are talking about, the context, that would determine what your possible elements could be. It's denoted by the letter U, the universal set. For example, if the context is about students who have Mr. Rappel as an instructor at Delgado, then U represents or consists of any student who has Mr. Rappel as an instructor at Delgado. But if the context is about students who are taking a math course at Delgado, then the universal set U will consist of any student who is taking a math course at Delgado. These would include the students who have Mr. Rappel as an instructor, but likely more. Now we define the complement of a set, B, to consist of all the elements which are not in B. To find the complement, you need to look at the universal set. Our notation is given right here. B, it looks like an apostrophe. That's what you want to call it. But when you see this notation, you are looking for the complement, and we associate the complement with the word not in the set. Suppose U consists of any student who is taking a math course at Delgado. If A is the set of students who have Mr. Rappel as an instructor, what would the complement of A be? Pause the video and try to answer that question right quick. You should have A complement is the set of students taking math at Delgado who are not students of Mr. Rappel. If a set A is contained in a set B, then we say A is a subset of B. And notationally, this is what we would be writing. A is a subset of B. Now note, when you see this notation here, there's one question you ask. Is everything on the left contained on the right? Now, if a set A is contained in a set B, but B also has elements that are not in A, then we call A a proper subset of B, and this is the notation that we work with. So the difference between the two notations is, notice the one above has what is really an equal sign, but the one below does not. For the one below here, proper subset, we have two conditions. Our first condition, everything on the left is contained on the right. The second condition, there are elements on the right side which are not on the left side. So we're going to go through a couple of true-false type questions. You should pause the video and attempt to answer them yourselves. Our first one, pause the video. Now, what we have here is the proper subset notation. Two questions. Is everything on the left contained on the right? The one is, the two is, but not the 57. So this is false. Pause the video. For this, we have the notation for a subset. Is everything on the left contained on the right? The A is, the B is, the 7. That's the only thing we have to ask because we're talking about a subset. We did not say if it was proper or not. The question, is it a subset? And the answer is true. I will note, it is a proper subset. That is correct. But it also is a subset. We only have one statement we have to satisfy for a subset, and it did. Everything on the left is on the right. Pause the video. For this one, we are asking, is it a proper subset? Is everything on the left on the right side? The A, the B, and the 7. But we also have a second question. Is there something on the left side, not on the right side? Is there something on the right side that is not on the left side? Yes, the 5. So it is true. Reminding you, don't edit my videos. You get it as it comes out here. All right? Hopefully I catch my little mistakes for you. All right, moving on. Pause the video. We are asking, do we have a proper subset? Well, the 1 is on the right side, the 3 is on the right side, the 7 is on the right side, and the 11 is on the right side. So the first condition is satisfied. It is a subset. But we asked, is it a proper subset? Is there an element on this side that is not on the left side? No. So this is false. One thing to note that you should keep in mind, the empty set is a subset of every set. No matter what set you're talking about, the empty set is always a subset. That you might need for one of these true-false type questions you could encounter on a test or something. The number of subsets for a set A is given by this formula right here, 2 to the n, where n represents the cardinality of the set. In other words, n is the number of elements in the set. For example, suppose we know a set has 4 elements. How many subsets does this set have? Well, 2 to the 4th power is 16. Suppose we have a set B given here. Can you determine how many subsets B would have? There are 6 elements, and 2 to the 6th power is equal to 64. So why is it important to know the number of subsets there are? Well, it can help us solve some application problems. For example, consider the following problem. At the World of 1,000 Po' Boys, you can elect to have any of the following condiments put on your po' boy. You can pick from mayo, ketchup, hot sauce, and grape jelly. So you decide what you would like on your po' boy. Your choices form a, can you fill in that blank? Of the set. Oh, wait. This collection of condiments forms a set. When you pick from this set, you are forming a subset. So, the number of different possible ways of adding condiments to the poor boy is simply the number of subsets of this particular set consisting of mayo, ketchup, hot sauce, grape jelly. Namely, fill in the blank. Well, we have 4 choices here, so that's 2 to the 4th power, which is 16. And this is important because the way I worded this problem, you could pick nothing, plain old poor boy, you could pick everything. In other words, the number 16 is all the possible subsets. That includes not having any condiments, the empty set. And the empty set we just finished saying is a subset of every set. Now, when you look at this problem here, you need to keep this in mind because you're going to see problems later on similar but different. And you have to be able to identify problems. It is very important to note here is that we are selecting from a list. This list here forms a set. But in the problem, we were not told how many we needed to select. We could select as many as we wanted, including none of them or all of them. This is important. This is an important distinction for what we're going to be doing in Chapter 10, because in Chapter 10, you're going to be told basically how many you can select. It might say you can only pick 1, you can only pick 2, or you can only pick 5. But here, we can pick anywhere between none all the way up to all of them. Okay, continuing on, some more definitions here. That's really what 2.1 and 2.2 is about. We're going to define the intersection of 2 sets to be a set that consists of what they have in common. So identify the word intersection with the word in common, and here's the notation we have. When you see this notation, you're going to think, what do they have in common? The union of 2 sets. When you hear the word union, you should consider that we are saying to combine the 2 sets into one. So union and combining. Here's the notation. When you see this notation, you want to combine the 2 sets, the set of elements in either of the 2. So here's an example. Once again, look at the problem, pause it, work it. Now that you're back with me, I am looking for the intersection, right? When you say intersection, you're asking, what do these sets have in common? Well, A and C have a 2 in common, a 4 in common, and a 5 in common. Pause the video for this one. We're looking for the union of the 2 sets. When we want the union, we're going to simply combine the 2. So we're going to grab everything from A. We did. Now we're going to look at C, because everything in C needs to be there. But it happens that we already have the 2, we already have the 4, and we have the 5. So that is the union. Pause the video. Again, we're looking for the union of 2 sets. So we're going to combine them together. We're grabbing everything from A, but then I'm going to go through B because, again, we're combining them. So I'm going to need the 2, I have it. I'm going to need the 4, I have it, but the 6 was missing. So notice I put the 6 in there. This is the union of A and B, or B and A. These operations are commutative. Pause the video for this last one. What do B and C have in common? Well, you're going to look for what they have in common. Since B has a 2, C has a 2, there's a 2 in common. They have the 4 in common, but they do not have the 5, or 6 in common. So here is the intersection of B and C. As in algebra, for more complex expressions, we work inside parentheses, we take care of complements, but otherwise we work left to right. So we're given sets U, A, B, and C, and we need to answer the following. So you need to find the following expression, its value. So pause the video, attempt it, and then play the video. Our first step here is to work inside the parentheses. So we're going to figure out what C union B is. So we're working with the union. So we're going to join B and C together. 2, 4, 6, and 5. Now our next step is to take the complement of that set. The complement is the opposite. It's what's not in this set. So what's not in the set, we go up and look at the universal set. 1 is not there. 2 is. 3 is not there. 4 is there. 5 is. 6 is. But 7 is not. So here's our complement. Now we want the intersection. What does set A have in common with this set? Well, if we look, A contains a 1, this set contains a 1. This set contains a 3, A contains a 3. They both contain a 7, nope. So just 1 and 3, that is the value of this expression. So notice how I worked things vertically. I kept track of what operations I was performing, and I explained the operation before I conducted it. Union, combine, complement, opposite, not there. Intersection, what do they have in common? Let's try this next one here. Pause the video. First step, we want to work inside the parentheses. What does A and B have in common? Looking at A and B, they have a 2 in common. They have a 4 in common. They don't have the 6 in common, or the 1, or the 5. You can see that, right? Now, what's the complement of A? Well, what is not in A? If you look at A is missing the 6 and the 7. So I actually did both operations at the same time, but you already know that. Sometimes you can do 2 things at once, right? Now I'm looking for the union. I'm going to just simply combine these together. So the 6, 7, 2, and 4. There's no order to a set, so it doesn't matter what order you came up with, so long as you have those 4 elements. Venn diagrams are visual means of showing the relationship between several sets. That relationship can be with respect to the elements of the set, of each set, or that relationship can be with respect to the number of elements in each set. Now we're going to start with the universal set, and it's going to be represented by a square box. So the world is contained in this square box because that's the universal set. Now the individual sets that we are referring to in a problem will be represented by circles. So I'm going to give you several possible examples below here. I'm going to talk about them a little bit. In our first example, apparently we're only considering one particular set, set A, and that set is represented by a circle. Anything and everything belonging to A is contained in that circle. Notice that circle is contained in the square box. All the circles are contained in the square box. Why? Because everything is in the universal set. In our second one, apparently we have 2 sets to consider. Set A is represented by one circle. Set B is represented by a second circle. But notice I overlap them. right here. And the reason why is because they might have something in common. Because if you belong to A, you have to be in the circle A. If you belong to B, you have to be in B. But it's possible there are some elements they have in common, the intersection. Our third example here, we have three sets. We have a set A, we have a set B, and we have a set C. So notice we were careful to overlap all of the circles because we have a lot of different possibilities here. They could be elements in common with all three sets. You may have elements that are only in A. You may have elements that are only in C. You may have elements that are only in B. So again, you have to take care of all possibilities, and outside here, there may be elements that are not in any of the three sets. So on the outside of these circles, you could have elements, because we didn't say the universal set was composed of all the elements in the sets we're talking about. No. The sets we're talking about are subsets of the universal set. There could be more out there. The idea, a Venn diagram will break up the universal set and the sets under consideration up into multiple disjoint regions. In other words, every element in the universe will belong to exactly one particular region. If you look down here, that's what we're talking about. Notice we have 8 different regions here. And depending upon your status determines where you would go and stand. So let's look at this problem. Consider the following. You were asked, which of the following sports do you watch? Basketball, football, or soccer? So anybody watching basketball would be standing in the basketball circle. Anybody watching football would be in the football circle. Anybody watching soccer would be in the soccer circle. So let's see. In this region here are those who only watch basketball. Because if you're up in here, notice you're outside the other 2 circles. So you can't be watching football or soccer. If you're standing here in the middle, you're watching all 3. Because notice you are in each of the 3 circles. If you're here, notice you're in the basketball and soccer circles, but you are not in the football circle. So in this region, you're only watching basketball and soccer. If you're standing outside the 3 circles, well, what do you think you are? You're watching none of them. So hopefully this will give you the idea of a Venn diagram. You got to keep in mind the regions that are formed here are disjoint, meaning they do not overlap. You got to keep in mind, for example, the basketball people are in the complete circle here. But again, depending upon their relationship with the other 2, they could fall in one of 4 different places. You got to keep that in mind. And there's also people that might not even be in any of the circles. Using the following Venn diagram, answer the below questions. So you should pause the video, attempt to answer the following, and then play the video. Keep in mind that this example, the numbers here represent elements. Later on, we will see the number could represent how many elements belong to a certain region. So once again, the context of the problem is important to understand. Here, we're talking elements, okay? Notice you have a bunch of numbers, all right? in section 2.3, we're going to look at a slightly different Venn diagram where we're actually counting how many elements belong in different places. So let's get started here. Determine the elements in the universal set. The universal set consists of all the elements. So every element you see here appears in the universal set. 8, 1, 3, 6, 0, 4, 2, and 9. Can you determine the elements in A? The elements in A are those that are contained in the circle associated with A. And those elements are 1, 3, 6, 0, and 4. Can you determine the elements in B? Well, anything in the circle associated with B, namely 0, 4, 2, and 9, are elements in B. And the last one, can you determine the elements in the complement of A? In other words, what elements are not in A? Well, all of these elements are in A, but also these elements. So you should have 8, 2, and 9 are the elements in the complement. I believe from this point forward, I'm going to start putting problems up that are similar to what you're going to see in ALEKS. For each statement below, you need to decide if it's true or false. So pause the video, try working out this problem. Try to answer the true or false questions here. Okay, here we go. In the first one, you're being asked about a subset. Is everything on the left on the right? The 11's on the right, the 13's on the right, and the 14's on the right. So it's true. The second one, again, you're being asked about a subset. Is the 5 on the right-hand side? No, it's not. It's over with. The empty set is empty. So this one's false. The third one, we're asking about a proper subset. Is everything on the left on the right-hand side? Nope. C is on the left, but it's not on the right. So that's a false statement. The last one. Now, we got a line through this one. Notice that. Since we have a line through it, the one on the left is not a subset of the one on the right. But it is a subset because the R is on the right side, the S is on the right side, and the V is on the right side. So this one is false also. Be careful with the true-false type questions. They're going to get you. You notice what I did. I explained the operator to myself, and I actually worked it out based upon the operator and the meaning of that operator. Here's our next example. You should pause the video, work it out. For the two sets that are given, I am being asked to find the intersection. What do these two things have in common? Well, if you look at it, they have a 2 in common, they have a 3 in common, and they have a 7 in common. All the other elements are not in common, so the intersection is 2, 3, 7. Let's pause the video and answer this one. You're being asked to find the union. The union simply means combine them together. So you're going to grab everything from M. That's what I did here. But then I'm going to go looking through H to make sure all those elements are there. I have the 2. I have the 3. I have the 7. But notice the 8 was missing. But I'm combining them. So I'll put the 8 in there. And this is the union. Okay, pause the video, read the problem. I'm not going to read it to you, okay? But you pause the video, read it, try to work it out. Welcome back. Wasn't that long, was it? Anyway, we're being asked to list the possible subsets, right? But I'm also asking you, can you tell me ahead of time how many subsets you should expect? Well, since the set consists of 2 elements, then there must be 2 to the second power, which is 4 subsets, right? My pen stopped working. I'm going to try to finish this one off without it. So here are the subsets. 1, both things can be in it. One of them, the other one, and nope, that's curly braces, which is empty, and the empty set. Remember, the empty set is always a subset. This is the one people tend to leave out for a very, I hate to say it, but simple problem here. And so notice again, I knew I should have 4. Why? 2 to the second power equals 4. Okay, here's our next problem. You need to pause the video and try to determine what this expression equals. Welcome back. All right, so working it out, the first thing we need to do is determine the inside of the parentheses, which contains a complement. So our first step is we are going to, I'm going to just write B down. I'm bringing down the union, but what's not in C? What is not in C? The 3, the 5, and the 9. So there's the complement of C. We're still inside the parentheses. You have to be careful. I have not done that outside complement yet. We are inside. We want the union. The union means combine the 2 together. Grab the 5, the 6. We need the 3. We need the 5. We have it. We need the 9. We have it. Now we are ready to take the complement, right? Ready to take the complement? What's not in there? Well, we are missing the 2. We have the 3. We have the 5. We have the 6. We have the 9. So 2 is the complement. Here's some lanyard. Pause the video. Give it a try. I'm working inside the parentheses first, right? What do B and C have in common? What they have in common, they have a 6 in common. I now need to deal with the complement. The complement means what's not there. Another way of saying it, the opposite. Well, if I look in the universal set, when you're looking for the complement, you're looking at the universal set. What is not there? The 2's missing, the 3's missing, the 5's missing, and the 9 is missing. So there's the value of that expression. So now we're going to up the game a bit. Pause the video, work out the problem, get back with me. Don't leave me hanging here. Turn it back on, okay? I'm waiting here in the World Wide Web, right? Out there in web world or whatever you want to call it. But work it out. Looking at this problem here, I'm going to work inside the parentheses here. But notice I decided to do 2 things at once because I can take the complement of C. What's not in C? The 1's missing. The 2's there. The 3 is there. The 4's missing. The 5 is there. The 6 is there. The 7 and the 8 are missing. So I took the complement of C. Now inside parentheses, I'm joining A with B. I grabbed everything from A. But then I had to look at B, and I noticed that the 8 and 9 need to be there because I'm doing the union. The union means join them together. I have not done the complement of this yet, but I will in the next step. I just brought this down. I brought the intersection down. What's not in this set? The 3, the 4, and the 5 are missing. Now what do they have in common? These 2 sets have a 4 in common. And so the answer is the set consisting of the element 4. In this example here, you are being given a Venn diagram. And based upon the Venn diagram, you are asked to answer the following in roster form, or if it's empty, express it as the empty set. So again, pause the video, try to determine A, B, and C. I'm glad you're back. Here we go. I want to know what's not in C. So I'm going to work with red here. Here is the set C. If you're outside of this circle, you're in the complement. So F, G, P, R, and X. Notice Q is part of the circle C. So Q is part of C, so it can't be in the complement. For B, we're going to go with purple here. I'm joining B and C together. I'm combining them. I'm grabbing the union. So I'm going to grab everything in B, X, and Q. I'm grabbing everything in C, Q, which I have, H, Y, and Z. That's the union. Now, I'm going to erase everything here, and I'm going to look at C. That way we have a little bit clear. Well, actually, yeah, there we go. All right, let's look at C here. That way we can just work with red again. All right, well, what do B and C have in common? Right here. I want the complement of that, though, right? So the complement is what's not there. Well, all of this on the outside is the complement. Now, you could go over here and you can work it out like we did in the previous example. That's up to you. But you should have come up with what's not in B and C. F, G, P, R. The X is not in the intersection. H, Y, and Z is not in the intersection. There you go. Okay, please pause the video, read the problem, try it, and then play the video. Okay, after reading the problem, we have a Venn diagram, and you're being asked to find how many types of animals were not treated by Dr. James. So here are the animals treated by Dr. James. So any animals on the outside of that circle, which there are 3 of them, is the number of animals that are not treated by Dr. James. B, how many animals were treated by Dr. James or Dr. Bryant? So Dr. James or Dr. Bryant, if you're in either one of these 2 circles, you were treated by one or the other. There are 1, 2, 3, 4, 5, 6, 7. So 7. Finally, which types of animals were treated by neither doctor? Neither doctor are the 2 on the outside here, which are goats and pigs. This concludes section 2.2. If you do have any questions, you can email me at the given address right here. Thank you.